Hello everybody. This lesson is about the unit circle and was completed by Asher Palmer, Lauren Vanderhorst, and Nicholas Blackford. The prerequisite knowledge that will be needed for this lesson are special right triangles, the coordinate plane, and trigonometric ratios. So, the first question we are going to answer is, what is the unit circle and why do we call it the unit circle? Clearly, by the name, we are going to be dealing with a circle. We are interested in finding some points that lie on the circle, so we're going to put the circle on the coordinate plane. In the coordinate plane, we have both the x-axis and the y-axis. Now for the reason that we call it the unit circle. The unit refers to the radius of the circle. In order to make the math as simple as possible, we're going to make the radius of our circle 1 unit. Because the radius of the circle is 1 unit, we can find these 4 points very easily. The point to the right is 1 unit to the right and 0 units up, also known as 1 on the x-axis and 0 on the y-axis. Here it is 0 on the x-axis and 1 on the y-axis. Here it is -1 on the x-axis and 0 on the y-axis. And at the bottom it's 0 on the x-axis and -1 on the y-axis. In order to find other points on this circle, we're going to investigate the triangles that are used and made by the x and y coordinates. Since the radius of the circle is 1, the hypotenuse of the triangle is 1. Therefore, we can get that the cosine of the x angle is x over 1, which equals x. And the sine of the angle is y over 1, which equals y. Similarly, the tangent of the angle is x over y, which is the sine of the angle over the cosine of the angle. It is important to note that the unit circle is a tool that will help us to know the sine, cosine, and tangent values for specific angles. Since we have investigated special right triangles already, we will be looking at the angles that make up these triangles. It will be a 30-60-90 and a 45-45-90 triangle. Therefore, we are going to be looking at 30 degrees, 45 degrees, and 60-degree angles. Recall, when working with trigonometric ratios, we are interested in finding the ratios of the sides of the triangles that we have created. Thus, we are going to be looking at the 30-60-90 and the 45-45-90 triangles, each with a hypotenuse of a length of 1. Let's first look at the 45-45-90 triangle. Recall that the side lengths in a 45-45-90 triangle are the ratio of a to a root 2. Thus, we can solve for a by setting up the equation root 2 times a equal to 1. By solving this, we have a equals 1 over root 2, which equals root 2 over 2. For the 30-60-90 triangle, we have the hypotenuse of 1, and the ratio of the side lengths are a to a root 3 to 2a. Thus, solving the equation 2a equals 1, we have that a is equal to 1/2, and a root 3 equals root 3 over 2. Now we will switch to Lauren and she will discuss how this relates to the unit circle.